In this video, we will discuss one of the concepts of chemistry, and that is what the metallurgy is a concept. Metallurgy. Metallurgy is a concept what we are selected to discuss in this class. Metallurgy is nothing but extraction of metal from some minerals. By some minerals. Extraction of metal from minerals is nothing but the discussion what we have as per metallurgy concept. What do you mean by that minerals? Minerals are nothing but naturally occurring chemical substances which you are going to find in earth crust. Or you can say that the compound containing or having metal is what we know as mineral. Right? They are naturally developed or naturally occurring in the earth crust. That means they are not man-made, they are not industrial made. When earth is existed, at the same time the minerals also existed like earth. That is what naturally occurring. So from that mineral we are going to extract the metal. But all minerals do not give metal when they are subjected to some processes. Right? All minerals do not give metal because if I consider some mineral, example I have to take your garden soil. Your garden soil containing iron, right? We can't able to extract the iron from that garden soil. Since of course we can able to extract, but it is very complicated one. With maximum effort, we will get very less amount of iron from that garden soil. If you take a mineral like hematite is a mineral. That mineral has the ability to give high percentage of metal and with minimum effort, and which is economically beneficial for us. In the industrial point of view, within low cost, we can able to extract iron from hematite ore when compared to your garden soil. Right? When compared to your garden soil, it is very easy with minimum effort, within low cost, and which is conveniently we can able to extract the iron from hematite ore. Hematite. That's why only by some minerals, and that such minerals are what we know as ores. Ores are nothing but the minerals. All ores are minerals, but all minerals are not ores. Since all minerals do not give the amount of metal what we need, the amount of metal. So the ores are nothing but the minerals which will give metal when they are subjected to some process, which will give, from which we can able to extract metal conveniently, and what we know as which is economically beneficial for us. That means within low cost we can able to extract the metal. That is what such a minerals are what we know as ores. Then in which what is the form of metal in ore or in mineral? What is the form? For example, if take based on the reactivity of the metal. Existence of metal is depends. For example, if you take your gold, silver, and which are known as noble metals, those noble metals are very low reactive. The reactivity of such a metals is very low. Therefore, they exist in native state. What is that native state? If you take AU exists as AU in a mineral. AU exists as AU, that is not present in any compound, or that does not convert it into any compound, since the reactivity is low. The metals which having low reactivity are exist in native state, whereas the metals having high reactivity, like you have potassium, sodium, magnesium, aluminium. These are the metals. Or you consider any metal which having high reactivity or present in compound form. They may be present in oxide form, they may be present in carbonate form, they may be present in sulfide form. Because of the reactivity of the metals, since they are high reactive, therefore they are going to react with other elements to convert into many compounds. This is what the existence of metal in a ore, or existence of metal in a mineral. By knowing about mineral ore as well as some brief introduction of metallurgy, we will come to know. I already told that in the beginning, metallurgy is the extraction of metal from the ore. Then, what are the steps we have to follow to extract the metal from ore? If I have a ore, I need to extract the metal from this ore. Then, what are the steps I have to follow? We have a general steps in the metallurgy, or general steps for the isolation of an element from an ore. And which are those steps? We will discuss. First, let me name that steps what I have. First is we have 5 steps as per the extraction of metal concept. The first step is crushing and grinding of ore. Crushing and grinding of ore. We have concentration of ore. Third step we have conversion of ore into metal oxide. Fourth one we have reduction of metal oxide, and fifth one we have refining process. These are the 5 processes. These are the 5 steps or 5 processes we have for the extraction of an element or metal from a respective ore. For example, if you take hematite, in that hematite containing iron metal. Right? For the extraction of iron metal from that hematite ore, we have to follow these 5 steps. About irrespective of metal, that means for the extraction of any metal from any respective ore, we need to follow these 5 steps. That's why these are what we know as the general steps of metallurgy, right? These are general steps of metallurgy. Now we will discuss one by one. First step of our metallurgy is crushing and grinding of ore. Of course, you will get mining. You will get mineral or ore by means of mining. By means of mining, you will get mineral. So first step of metallurgy, you have to convert that ore into fine powder like structure, fine powder form. Why I have to convert that into fine powder form? Because to proceed the further steps like concentration of ore, conversion of ore into metal oxide, and to proceed the further steps, first you have to convert the ore into fine powder form. That was done by machines. We have in industries we have machines like jaw crusher or ball mills, or you can say that rod mills. These are the machines what we have to convert the ore into fine powder form, and that process is what we know as pulverization. Pulverization, that means the process in which the ore is converted into fine powder form by using the machines like jaw crusher, ball mills, or you can say that rod mills. Right? And that is the first step. After first step, we left with the ore which is in powder form. And second step is concentration of ore. You know, when the ore is in the earth crust, the ore containing impurities like sand particles, earthy particles, and undesired materials. Undesired materials is nothing but the ore is consisting of sand particles, mud particles, stones. These are some impurities which comes along with the ore. Right? That is also present in the powder form of ore. So to remove these impurities, I have to do concentration of the ore. Concentration of the ore is nothing but removal of impurities. Removal of impurities. Removal of impurities results in the concentration of the ore. Removal of impurities results in the concentration of the ore. And these impurities are collectively called gong or gang. These impurities are collectively called gang. I have to remove this gang to get a metal. In that ore, I have impurities and I have ore particles. I need ore particles only. For that, I have to remove the gong particles. So, to remove the gang particles in the ore, I have some methods for the concentration of the ore. And which of those methods let me discuss. Right? The physical methods for the concentration of ore, we have first step hydraulic washing. First step is hydraulic washing, or you can say that gravity separation. Gravity separation method. This method is favorable when there is a difference in the density of the ore particle and what the impurities what we have. That means the density, when you compare the density of the ore particle with the impurities, it must be heavier in density, whereas the impurities must be lighter. And that especially the oxide ores. The oxide ores are generally subjected to this hydraulic washing. Hydraulic washing, in which the ore particles has heavier density compared to the impurities what it has. So when you see the setup of that hydraulic washing, this is the setup what we have. At this position, we are going to kept the powder form of ore, And now we are going to pass the stream of water. When I pass the stream of water, the lightweight impurities or move along with the water like this, or move along with the water. This is what impurity. But the heavier density ore particles are settled at the grooves. This is down-like structure or nothing but grooves. This is down-like structure or nothing but grooves. At this position or at this point, you are going to find out the ore particles which having higher density, but the impurities which having lighter in weight or move along with the water. Thereby, we will come to what separate the impurities from the ore particles. This is a one method for the concentration of the ore when there is a difference in the densities of the ore particles and what impurities. And that too, ore particles has to be higher density and that impurities having lightweight in density. At that time, we will use the hydraulic washing method, or you can say gravity separation for the concentration of the ore. And now come to discuss second. Let me discuss second method for the concentration of ore. We have magnetic separation. For this process, among ore or gangue or impurities, one should be magnetic and one should be non-magnetic. Right? One should be magnetic in nature and another should be non-magnetic in nature. When you see the setup for this magnetic separation, we have two magnetic fields. These are the two magnetic fields, and this is what conveyor belt. Here we made the ore particles to move on this. This wheel is running, and we are made this ore particle to flow on this, and we have a two container. The particles like impurities or non-magnetic in nature are going to come collect here, since they are not affected by the magnetic field. They are not affected by the magnet. But the magnetic materials are affected by the magnet. At this position, they are going to collect. These are the impurities. These are the ore particles. Since the ore particles are in magnetic nature, whereas these are non-magnetic in nature. Therefore, they are going to collect here, and these ore particles are going to collect here. This is a one method for the concentration of ore when there is a difference in the magnetic nature. That means one should be magnetic in nature and another should be non-magnetic in nature. Now, we have a third method for the concentration of ore. That is what flotation process. This is a third method for the concentration of the ore. Especially this method is favorable for sulfide ores. If we have a sulfide ores like PBS, ZNS, these are what we know as sulfide ores. And these sulfide ores are generally concentrated by flotation process, because in sulfide ores the ore particles are lighter in weight. But the impurities are very high in weight. That means have very weight. At that time we will use the flotation, and the flotation is nothing but take a container. This is a container. This container is filled with water. To this water I am going to add the ore of sulfide. Sulfide ore. Along with that I am going to add pine oil, or you can add the fatty acid. This fine oil or fatty acid enhance the ore particles to non-wettability to the water. That means this fine oil will prevent the ore particle to from the wetting of the water. When I add the ore particles, the impurities are settled down at the bottom. The impurities are settled down at the bottom of the container, whereas the ore particles are wetted by this oil. They are float on the surface. Now I am going to agitate this. Solution. I am going to get a froth on this because of the pine oil, and that froth was stabilized by some froth stabilizer. We have cresol and we have aniline. These are the two compounds what we are using for the froth stabilizer, as a froth stabilizer. These two stabilizes the froth, and as we are going to extract this froth, we are going to take off this froth to a separate container, and this container containing mineral froth. Since the impurities are settled down at the bottom of the container, whereas at the surface we have a fruit which containing mineral, and we are going to take off that mineral or mineral fruit from that container to a separate container for the further process. This is a one method for the concentration of the sulfide ores. And these are the three steps what we have for the concentration of the ore. Now, after concentrating ore, we have third step, that is what? Conversion of concentrated ore into metal oxide. Why I have to convert the concentrated ore into metal oxide? Here we have a concentrated ore and concentrated ore. I have to convert it into metal oxide. This is the third step what I have. First of all, why I have to convert it into metal oxide? If I convert concentrated ore into metal oxide, I will get metal oxide. When I make this metal oxide to undergo reduction is nothing but removal of oxygen. If I remove oxygen from metal oxide, I will left with metal. Right? I will left with metal. When metal oxide will undergo reduction, there is a removal of oxygen takes place, and I am going to left with metal. So this is what I need. That's why I am going to convert the concentrated ore into metal oxide. After, I will make this metal oxide to undergo reduction by treating with some substance. I will make this metal oxide to undergo reduction. Thereby, I will get metal. That's why I am going to convert the concentrated ore into metal oxide. So, to convert concentrated ore into metal oxide, we have two processes. And the first process, what we have, roasting. Roasting is the one process which we are using to convert the concentrated ore into metal oxide. Example for that we have ZNS. Especially sulfide ores are roasted. Sulfide ores are subjected to roasting process to convert into metal oxide. For example, you can say that the zinc sulfide, that is calamine ore, is roasted. Right? That will give zinc oxide plus sulfur dioxide gas. Here we will get metal oxide. Then, first of all, what is roasting? First of all, roasting is nothing but heating of the ore particle, heating of the concentrated ore below its melting points at a temperature below its melting point in the presence of oxygen. That means we are going to heat the ore, concentrated ore in the presence of air at a temperature below its melting point. That is what roasting. And by after roasting, we will get metal oxide. And another example we have PeBs plus O2 will give you PbO plus SO2. Here we will get metal oxide. These are some example of roasting. Roasting is nothing but heating of ore at a temperature below its melting point to get metal oxide in the presence of oxygen or in the presence of air. And we have another step to convert the metal oxide, to convert concentrated ore into metal oxide, and that is what calcination we have. That is nothing but calcination. In case of calcination, the ore is heated at a temperature below its melting point in the absence of air. Especially the carbonate ores or undergo calcination. We have calcium carbonate. It is a limestone. We are going to heat this calcium carbonate at a temperature below its melting point in the absence of air. In the absence of air, we will get calcium oxide plus CO2. This is what calcium oxide. This is metal oxide, right? And we have ZnCO3. This is heated in the absence of air. We will get zinc oxide plus CO2. These are the two methods what we have for the conversion of concentrated ore into metal oxide. Right. After converting concentrated ore into metal oxide, we have to remove the oxygen from the metal oxide, and that process is what we known as reduction of metal oxide. That is what reduction process. We are going to reduce the metal oxide into metal by removing oxygen. Right. So to reduce, I have to treat metal oxide with some substances like coke and carbon monoxide. When I treat metal oxide with coke and carbon monoxide, these two having high affinity to attract oxygen. Thereby I will get metal. That is metal oxide. When treated with coke, it will give metal plus carbon monoxide. Example for that we have when zinc oxide is treated with coke, I will give zinc plus CO, or PbO, lead oxide plus coke, Pb plus CO. PbO when treated with carbon monoxide, that will give Pb plus CO2. That means coke and carbon monoxide as high affinity to attract the oxygen. It is only for the metals having reactivity, intermediate reactivity. If the metal having high reactivity, here zinc and lead has very intermediate reactivity. They are not low reactive and they are not high reactive. They are in between that. But if you take aluminium oxide, that means aluminium oxide was not reduced by carbon and carbon monoxide, since the reactivity of that metal is very high. So the metal oxide of high reactive metals can be reduced by the process electrolysis. Through electrolysis, we can able to what? We can able to reduce the high reactive metals. But the metals having reactivity in between high and low, we can able to reduce that by treating with carbon, or you can say coke and carbon monoxide. Right? This is what the reduction of the metal. Oxide. After this, we will left with a metal which having some impurities also. After reduction, we have a last process. That is what refining. Refining, or you can say that purification process. After reduction, you will left with metal, but that metal also has some impurities. To remove that impurities, what it has, we have several methods. And the first method, what we have, distillation. Second method, what we have, electrolysis. Third method, we have zone refining. Fourth, we have vapor phase refining. And fifth, we have chromatographic method. These are the several methods what we have for the purification of metal, what we get after the reduction of the metal oxide. After the reduction of metal oxide, we will get some metal. That metal also contains some impurities. To remove that impurities, I have to do several I have to do refining, that is purification, and that was done by these methods. Especially for a different metal, we have based on the nature of the metal and based on the reactivity of the metal, we will use some methods. That's why just you have to remember this in further classes when we discuss the specific extraction. That is, when we discuss the specific metal extraction, at that time I will explain the process of refining. And this is what some brief glance about introduction of metallurgy. Thank you.